Welcome to Chapter 7. We are starting to get into more algebra-based chapters, so I think for a lot of you this is going to be a pretty good thing. Chapter 7 is all about polygons and the different angle measurements of polygons, the number of diagonals, and a lot of different things that we're going to approach later on. But for now we're focusing on triangles, and we have three theorems that we're going to cover. The first is called the angle sum of a triangle. And I know a lot of you coming in probably already knew this, but we're going to pretend that we didn't. The angles of a triangle are going to add up to a set number, and we can find out what that number is. So if we look at this little application on the internet, we'll notice here that we have a triangle ABC. We have three angles, 83 degrees, 67 degrees, and 30 degrees. And when I put them together, I get 180 degrees. So if I drag this orange dot around, you'll notice that my angle measurements are changing, but the sum is not. All three angles added up are still going to equal the same thing. They're still going to equal 180 degrees. And so that's really kind of the main thing for that particular theorem, is that if I add up all angles of a triangle, the sum of the angles, they're going to equal 180 degrees. So a quick algebra-based example on this. We have three triangles that are showing up here. We've got this large triangle with a 90 and 75. We've got another triangle with a 70 and 45. And then we have this triangle on the inside. In this diagram, I want to find x, y, and z. So the first thing I'm going to do is consider this triangle with a 90 and 75. 90 plus 75 plus x has to equal 180. So when I add these together, I get 165 plus x equals 180. And I find out that x is 15. Again, using the three angles of a triangle add up to 180. I do the same thing for angle y. I do 70 plus 45 plus y equals 180. Add these up, I get 115. And when I take that away from 180, I get 65. So x is 15 and y is 65. Next thing I'm going to do is put these together. 15 plus 65 plus z equals 180. This is 80. Take it from 180, you get 100. So y is 65, x is 15, and z is 100. The next theorem is called the exterior angle theorem. And it says that our definition of an exterior angle is an angle that's adjacent to, and that means next to, and supplementary to an interior angle. They're going to be right next to each other. They're going to form a straight line. We look at our diagram. This angle B, right here, the one that's changing, is our exterior angle. It's outside. We have an angle A and an angle C, which are called remote interior angles. Now, if you look at the relationship between those, I've got a 42-degree angle and a 111-degree angle. And when I add them up, I get my exterior angle, which is 153. So it seems like if we take our remote interior angles, we add them up, we get our exterior angle. So again, the angles that are inside but far away from the angle. Well, let me move A around and see what happens. I've changed my angles. Now I've got a 77 and a 63. But when I add those up, I get 140, which is the exterior angle that's listed out there. I can move B, and the same thing's going to happen. 57 plus 61 is still going to be 118, my exterior angle. I can move C. 101 plus 28 gives me my exterior angle. So that relationship is true, that the remote interior angles add up to the exterior angle. And that's what the theorem says. The measure of an exterior angle is equal to the sum of the remote interior angles. So as a quick example with this, we have an exterior angle here, 16x plus 20, and these are the remote interior angles. And I want to find the measurement of angle E. So my equation is going to be the exterior angle equals the sum of the remote interior angles. So when I put these together, I get 16x plus 20 on this side still. And on the other side, I get 10x plus 38. So I'm going to take 10x away, and I'm going to take 20 away, and find out that x is 3. Once I have the value of x, take it back in and plug it into angle E. 21 plus 13 gives me 34. That's the exterior angle theorem. Exterior angle equals the sum of the remote interior angles. And our last theorem is called the midline theorem. So let's take a look at this application and see what's going on here. So we have a diagram here. This is a midline theorem. What it's saying here, this segment is the midline, and I know that because it connects the midpoints of opposite sides. And what ends up happening with the midline is it's not only going to connect the midpoints of the side, but it's going to be parallel to the next side. And we'll talk more about that in Chapter 8 and why that's significant and why we need to know that. It has to do with similar triangles, but we're not quite there yet. But if you notice there's a relationship between these sides, or seems to be. The midline looks like it's half of this side. 18.5, if I multiply that by 2, I'd get 37. So let's see what happens if I move this around. If I move these points around, there we go. 16 and 32. 14.6, I multiply it by 2, it's 29.2, it's 29.1 based on here, but that's a pretty close measurement. 16.6 times 2 is going to give me 33.3. So you notice there's that relationship, that the midline is going to be half of that third side. So a segment joining the midpoints of two sides of a triangle is parallel to the third side and half as big. In Rn in the following diagram, we know that Rn is going to be, if SL is 16, then Rn is twice that, which is 32. Not only is it half as big, it's also going to be parallel to SL, or SL and Rn, but again, that's not really incredibly important for us to right now because we're only concerned about the measurements.